Hello everyone, this is Vishalvi, Assistant Professor, Department of Chemistry, Iroda Arts and Science College 2. Today we are going to learn about D block elements and their general properties. It is one of the most important topics in inorganic chemistry. Okay, let's me start. The transition elements. The transition elements defines as those which as elements or ions have partly filled d subshells. If the d subshell is partly filled, the elements are known as d block or transition elements. The transition elements have three rows: first, second, third rows. If we see the first transition series, the elements from scandium to zinc constitute the first transition series. The 3D subshell starts filling up. Outermost electronic configuration of first series shown below. In this case, chromium and copper, unlike others, have single electron in the 4s orbital. This is due to the additional stability gained by the atom when the d subshell is exactly half filled or completely filled. Accordingly, on the 4s electrons move to the 3D level in the atoms of chromium and copper. The 3D level in the case of chromium gets exactly half filled, and that in the case of copper gets completely filled. Elements of the second transition series. The elements from yttrium to cadmium constitute the second transition series. 4D subshells begins filling up. Outermost electronic configuration of the second transition series is given below. The molybdenum has 4D5, 5s1. Silver has 4D10, 5s1. Can be easily understood on the basis of higher stability of exactly half-filled and completely filled subshells as in noticed in chromium copper. This concept cannot explain the anomalous configuration of niobium, ruthenium, rhodium, palladium. Nuclear electron interactions determining these configuration that also cannot be said in the present study. Elements of third transition series. The third transition series starts from hafnium in the filling of 5D subshell begins. The outermost electronic configuration is 4f14 5d2 6s2. General characteristics of D block elements: metallic character, molar volumes and densities, atomic radii, ionic radii, melting points and boiling points, ionization energies, reactivity, oxidation state, reducing properties, color, magnetic properties, catalytic properties, density to form complexes. Metallic character. All the transition elements are metals. This is to be expected since the number of electrons in outermost shell is very small, being only 1 or 2, which can be easily lost. They are good conductors of heat and electricity. They are malleable and ductile and forms alloys with several other metals. The difference from non-transition metals in being hard and brittle. Mercury is exception, although hardness and brittleness are associated with covalent bond between the metal atoms. Metallic bonds cannot be denied because these are good conductors of heat and electricity. Covalent and metallic bonding exists among the atoms of the transition elements, which the overlapping of unfilled d orbitals of the metal atoms causes covalent bonding. The valence s electrons cause metallic bonding. Copper, silver, gold are particularly outstanding in their thermal and electrical conductivities. Molar volumes and densities. There are much lower than those of S and P block elements of neighboring groups. The inner orbitals get filled. The increased charge pulls the electrons inward. Therefore, the molar volume decreased. Decreasing molar volume, there is corresponding increase in density. The Transition elements of densities are quite high. Most of the elements have densities greater than 5 grams centimeter minus 3. Scandium, titanium, yttrium with 3.01, 4.51, 4.47 grams centimeter cube respectively. Atomic radii. The atomic radii of the transition elements of a given series are seen to decreases generally with increase in the atomic number of as from the fact. Increase in the nuclear charge would tend to attract the electron charge inward. Chromium to copper radii are very close to each other due to the addition of electron screens. The outer electronic configuration from the inward pull of the nucleus. Size of the atom does not alter much in moving from chromium to copper. Ionic color. The most of the transition elements are colored both in solid and liquid aqueous state. Generally, the elements are ions having unpaired electrons produced colored compound. Magnetic properties. When a magnetic field is applied to substance, mainly two types of magnetic behavior observed: diamagnetism and paramagnetism. Diamagnetism substances are repelled by the applied field, while the paramagnetic substances are attracted. Substances which are attracted very strongly are said to be ferromagnetic. In fact, ferromagnetic is an extreme form of paramagnetism. Here are the magnetic field, paramagnetism and ferromagnetism. Oxidation state of the transition elements. Transition elements have variable oxidation state due to very small energy differences between n-1d and ns subshells electrons from both the subshell take part in bonding. The elements which are the greatest number of oxidation states are occur in the or near in the middle series. Manganese, for example, exhibit oxidation state from +2 to +7. Low oxidation states are found when a complex compound has electrons capable of high acceptor character in addition to sigma bond. For example, nickel, cobalt 4 and iron cobalt 5. The oxidation state of nickel and iron is 0. Catalytic properties. Vanadium finely divided ion, nickel, cobalt. This property is due to the presence of unpaired electrons in the incomplete d orbitals. Variable oxidation states of transition metals in most cases provide large surface area with free valencies, tendency to form complexes. Complex compounds are those in which the metal ions bind a number of anions or neutron molecules, giving complex species with characteristic properties. The transition metals form a large number of complex compounds. A few examples are FeCN6 3-, FeCN6 4-, CuNH3 4 2+, and platinum Cl4 2-. Thank you.